We can refer to relative atomic mass or to molar mass. Atomic mass refers to the mass of one atom. So it's a very small mass. And we usually use the unit atomic mass units to measure the mass of a single atom because it's so tiny. It will give us such a tiny answer if we use another unit like grams or kilograms. That's why we need a unit of its own, Molar mass refers to the mass of a whole mole of, for example, atoms or molecules or whatever. A mole of atoms is 6,02 times 10 to the power 23 atoms. So that is many atoms. And so molar mass is a lot heavier than atomic mass. So it is measured in the larger unit, grams. Related to atomic mass is molecular mass or formula mass. And that's the mass of a single molecule or formula unit, also measured in atomic mass units. We can find atomic masses or molar masses in the periodic table. These numbers here for each of these elements give the atomic mass, if in the unit amu, or the molar mass, if in the unit grams, of each of these elements. Pause the movie while you complete this table with this information about the symbols here, or formulae, the relative atomic or molecular masses in this column, and in this last column, the molar masses in grams. Carbon. We can see the atomic mass or molar mass of carbon is 12. That means that one carbon atom has a mass of 12 atomic mass units. And a whole mole of carbon atoms, in other words 6,02 times 10 to the power 23 of those carbon atoms. So not just one of them, but this huge number of them. Also has a mass of 12, but it's not the same meaning as 12 amu. It's now 12 grams, which is a lot heavier than 12 amu. It's 6,02 times 10 to the power 23 heavier. Even though the numbers, of course, are the same, 12 and 12, but the units are not the same, and therefore the meaning is not the same. Here we have one oxygen molecule, O2, and each oxygen molecule has 2 oxygen atoms in it. The mass of each of those oxygen atoms is 16 atomic mass units. So 2 of them together have a mass of 32 atomic mass units. 1 mole of oxygen molecules is 6,02 times 10 to the power 23 of these O2 molecules. And it consists, that 1 mole of oxygen molecules consists of 2 moles of oxygen atoms. Because if you had 6,02 times 10 to the power 23 of these oxygen molecules like this, I can't draw them all because that's far too many, but just try and imagine this huge number of oxygen molecules here, and then we split it up and put 1 atom from each molecule in a pile there to the left, and the other atom from each molecule in a pile to the right. Then we would have 2 piles. And how many O atoms would be in each pile? It would still be this number, 6,02 times 10 to the power 23 in each pile. So now you would have 2 piles of 6,02 times 10 to the power 23, but each pile now would be an O atom, not an O2 molecule. So that's why we say 1 mole of O2 molecules contains inside it 2 moles of O atoms. Each of those moles of O atoms has a mass of 16 grams. The 16, when written in grams, means the molar mass of O. And now there are 2 such moles in 2 moles of O, which is 1 mole of O2. And so the mass of 1 mole of O2 molecules is 32, but now grams. So notice we get the same answer numerically, whether we're speaking about 1 O2 molecule or 1 mole of O2 molecules. It's 32 in both cases, but the unit is different, and therefore the meaning is different, amu and gram. Here we have a carbon dioxide molecule. Each molecule of carbon dioxide contains 1 carbon atom and 2 oxygen atoms. That 1 carbon atom has a mass of 12 atomic mass units, and each of the oxygen atoms has a mass of 16 amu. So 2 of them together have a mass of 2 times 16 amu, which is 32 amu. 32 plus 12, 44 atomic mass units is the mass of one single carbon dioxide molecule. What about a mole of carbon dioxide molecules? A whole mole of carbon dioxide molecules contains within it 1 mole of carbon atoms and 2 moles of oxygen atoms. Each mole of carbon atoms has a mass of 12 grams. Each mole of oxygen atoms has a mass of 16 grams. So 2 of them together have a mass of 32 grams. So altogether, 1 mole of carbon dioxide molecules has a mass of 44 grams. Pause the movie while you answer this page yourself. Here we have a lead oxide molecule. One lead oxide molecule has 1 lead atom with a mass of 207 atomic mass units, and it contains 1 oxygen atom with a mass of 16 atomic mass units. 207 plus 16 gives 223 atomic mass units is the mass of 1 lead oxide molecule. That is the molecular mass, or the relative molecular mass of lead oxide. Now, a whole mole of lead oxide contains inside it 1 mole of lead atoms and 1 mole of oxygen atoms. The lead atoms have a mass of 207 grams. It's now a mole of them, not just one of them, but a whole mole of them. That's why it's 207 grams. And the whole mole of oxygen atoms has a mass of 16 grams. So the whole mole of lead oxide has a mass of 223 grams. Here we have sodium carbonate, Na2CO3. We can see that 1 formula unit, this is now called a formula unit, not a molecule. Why? Because this is an ionic substance. So 1 formula unit has 2 NAs. We can see that little 2 there means that there are 2 NAs for every 1 C and 3 O's. So that's 2 Na atoms, each of which has a mass of 23 atomic mass units. And then there's 1 carbon atom, which has a mass of 12 atomic mass units. And then we have 1, 2, 3, that's why there's that little 3 down there. 3 oxygen atoms, each with a mass of 16 atomic mass units. So all of these together, 2 times 23, which is 46, plus 12, plus 3 times 16, should put that in brackets, is equal to 106 atomic mass units. 1 mole of sodium carbonate contains 2 moles of sodium atoms, each of which has a mass of 23 grams. So it's 2 times 23 grams now, because now we're speaking about a mole of sodium atoms, not just a sodium atom or 2 sodium atoms. Contains 1 mole of carbon atoms, which has a mass of 12 grams, not atomic mass units. It contains 3 moles of oxygen atoms, which has a mass of 3 times 16 grams. That altogether has a mass of 106 grams. Again, pause the movie while you answer this yourself. Here we have iron, Fe, a single atom, and 1 single atom of iron has a mass of 55,8 atomic mass units. If we have a whole mole of these atoms, the mass is still 55,8, but not atomic mass units, it's grams. Here we have 1 calcium hydroxide formula unit, Ca bracket OH bracket 2. Notice what that means. We have 1 calcium there, and then we have 2 OH units. That's what that little 2 there means, outside of the brackets, and inside the brackets we have OH, meaning there are 2 OHs for every 1 calcium. So this 1 formula unit has a mass of 40 atomic mass units for the calcium there, plus 2 times 16 for the 2 O's, again atomic mass units, plus 2 times 1 for the H's. That's 40 plus 32 plus 2 is equal to 74. And remember, this is referring to one formula unit, atomic mass units. For a mole, we can do the same calculation, but we realize, of course, we get the same answer numerically, but it means something very different because the unit is different, grams. So that's the molar mass of a whole mole of these. 6,02 times 10 to the power 23 of these have a mass of that. A whole mole of calcium hydroxide, 74 grams. Ammonium nitrate. One formula unit has 2 N's in it, each having a mass of 14 atomic mass units. So that's the N's taken care of. And then there are 4 H's, each having a mass of 1 atomic mass unit, and 3 O's, each having a mass of 16 atomic mass units. 2 times 14 is 28. We add 4 plus, open our brackets, 3 times 16, close bracket, equals 80 atomic mass units. That is the mass of one formula unit. 6,02 times 10 to the power 23 of these formula units will have a mass of 80 grams. That's the molar mass of ammonium nitrate. You try this yourself before I show you the answer. CH3COOH has 2 C's, each with a mass of 12 atomic mass units, plus those 3 plus that 1, 4 H's, each with a mass of 1 atomic mass unit, plus these 2 O's, each with a mass of 16 atomic mass units. 2 times 12 is 24, plus 4 plus 2 times 16 is 32, equals 60, and this is a formula unit, so it's atomic mass units. When we have a whole mole of them, it's also going to be 60, but now grams. Here we have iron sulfate with water of crystallization. This .7H2O refers to this water of crystallization over there. So it's water molecules bound into the crystal lattice. And this whole unit over here is one formula unit. And that one formula unit, what is its mass? The Fe part contributes 55,8 atomic mass units per formula unit. Then there's one S, 32 atomic mass units, plus here we have 4 O's there and another 7 there. That 7 refers to the H2 and the O. So that makes 11 O's all together. So we have 11 O atoms, each of which has a mass of 16 atomic mass units. And then there are 14 H's, each with a mass of 1 atomic mass unit. So the formula mass of this whole thing is 55.8 plus 32 plus 11 times 16 plus 14, which is equal to 277,8 atomic mass units. A whole mole of these formula units has a mass of 277,8 grams.